Right, so it's time now for the cosine rule. Having done the sine rule, and hopefully you've done the questions from the exercises on that cosine rule, and then we'll break for a couple of weeks, and we'll get back together and continue with trigonometry after the term break, which I hope is an excellent one for you. But before we get to that point, let's examine what this cosine rule can do to help us out. So what we've got is we've established that there's a rule we can use for non-right angle triangles. That's the sine rule, really easy to remember. A over sine A equals B over sine B equals C over sine C. Flip it for angles that you're trying to find. Doesn't get all the information for us. For instance, if we've got three sides, three angles, 40 degrees, 80 degrees, and 60 degrees, what's this side here? Well, we don't. X over sine 60 equals, there's nothing to go on. Sine rule doesn't do it. So there are certain situations the sine rule works for, but not all of them. So, of course, the mathematicians of the day weren't happy with this situation. So they started playing around again with triangle ABC, no doubt. Probably looked a lot like this one. And they said, let's talk right-angled trigonometry again because we're awesome at that. And so labeling the sides, doing all this business. But we need to come up with something different here. Let's label this length here x. That's from there to there, which would mean this whole side is a from there to there, which means this side here is a minus x on this right angled triangle here. So let's do some Pythagoras on this stuff. So with this left hand side here, c squared is very simply equal to x squared plus h squared. That's not groundbreaking. And over the other side here, we've got b squared equals h squared plus a minus x squared, which needs a little bit of work. H squared plus a squared minus 2ax plus x squared. So we've got b squared equal to that. And we've got c squared equal to this. Now, what we could do here is take a result from here and put it in over this side. So we could say from this that that h squared is equal to make h squared the subject. That's equal to c squared minus x squared, and we could put that in over here. You see, so if we put that in for h squared there, then we get, change the colour, b squared equals c squared minus x squared plus a squared minus 2ax plus x squared. So the x squareds go, and we're left with c squared plus a squared. I'll change that around to a squared plus c squared minus 2ax with the x squareds going. C squared plus a squared, or a squared plus c squared minus 2ax. That's b squared, which is great, but we're not always going to have this, so are we? We're just going to have sides a, b, c. In fact, we're never going to have this. So we need to get x out of there. How can we write x in terms of, well, a's and c's ideally? So if we take x cos, if we just do some cosing of b, would that be useful? Could it be useful? Cos b equals x over c. X is equal to c cos b. Wow, if we can then put that in there, now we've got b squared equals a squared plus c squared minus 2ac cos b. Now we've got a result in just a's, b's, c's. No h's and no x's. And that looks good. That looks really good. It's more often, so what this says is you can take, you can find the square of a side by knowing these other two sides. This is B, the other two sides A and C, the other two sides, and the angle it's opposite the side trying to find. So this is also or C squared equals A squared plus B squared minus 2AB cos C. That's how it's most often represented, the cosine rule, for sides, to find an unknown side. For unknown side, we make cos C the subject of that to find for an unknown angle. So cos C equals, if you think about it, it's A squared plus B squared minus C squared over 2AB. That will get you the angle C. So this, you'll use this for unknown angle. Okay, so let's do an example or two. Go to exercise 11I. Exercise 11I, it's on page 389. And we're going to do question 1, A and D. So that I'm not doing any of your work requirements. Oh no, not A and D, B and D. Beg your pardon. So question 1B. Let's see how this works. A is 20, B is 33, so we've got three sides, a bit like I put up before. It's got three sides of a triangle. A is 20, so we'll label it A, B, C. So A is 20, B is 33, and C is 41. Find, I use the given information to find all sides and angles. We've got all the sides. Which angle do you want to find? Doesn't matter, let's find C first. So this will be, or cos of this will equal, think about it back up here, it's going to equal, okay, this side squared plus this side squared minus this side squared. So 20 squared plus 33 squared, doesn't matter which order you write those in, but it does matter that the 41 squared is subtracted at the end, over 2 times 20 times 33. The side opposite the angle trying to find only comes up once, and that's just it there. So cos C will equal, I'll just get the calculator out for this, 20 squared plus 33 squared. It'd be good if you were working this out at the same time, minus 41 squared. I always like to hit equals and then divided by open bracket. Where are my brackets? There we go. 2 times 20 times 33, so 40 times 33. Hit enter. We have minus 8 over 55, that's cos C. So C will equal cos inverse 8 55ths. So what I need to do now is go to cos inverse, no, that's tan inverse. Cos inverse of, put a fraction in, 8 over 33. Enter. You get 75.9 or 76.0 degrees. So that's C. Find one more angle and we'll note the third one by angle sum. We could use the sine rule now that we've got that at 76. We could say that therefore we could now use the sine rule for sine A over 20 is equal to sine C, which is 76 over 41. The sine rule is much easier to do. 20 sine 76 over 41, so A will be sine 20 sine 76 over 41. So we're going to go for sine inverse 20 sine 76, 20 sine 76 divided by 41, and hit enter. That's 28.2 degrees. And if C is equal to 76, then B must equal 180 minus the last answer, then subtract 76, and we get, excuse me, B to be 75.6 degrees. Two decimal places. So lots to do with those questions because they want you to find out more than one. Go to D. Just quickly have a look at D. D gives us an angle, B31. Doesn't matter where you put it. B is 31, A is 10, there's C is 14. That's the information we've got, and we want to find out all the other bits. But let's find out the side AC. So we use the side rule. AC squared equals 14 squared plus 10 squared minus 2 times 14 times 10 times cos of 31. Let's have a look at that. C squared, A squared plus B squared minus twice AB cos C. So it's this squared is equal to 14 squared plus 10 squared minus 2 times 14 times 10 by cos of the angle opposite the one you're decided trying to find. So put all that into the calculator. 14 squared plus 10 squared, 14 squared plus 10 squared minus 2 times 14 times 10 times cos 31. Hit enter, but then take the square root of that result to get 7.48. So AC is equal to 7.48 units to 3SF. Okay, so there's an example using the cosine rule for sides. An example up here using it for angles. There's the formula. Hopefully you've got good notes on this. Enjoy your last lesson. I'll see you next term. Have a great term break.